So I basically wanted to discuss the isolation problem that we're discussing for new workflows, and kind of first discuss that and also talk about some solutions. So the main problem we have is that Docker doesn't provide any sort of kernel isolation, right? So it's really segregation that it does. And so the idea is that if I have, let's say I'm running Docker desktop on my Mac or Windows or even Linux, it spins up this Docker VM, and this Docker VM then runs multiple containers. So let's say there's a workflow container and there's another, I'm running a service or something. They all share kind of the kernel, right? And so the problem here is that if you are escaping the kernel here, so if somehow we are able to escape this kernel, if there's some sort of violation or some sort of code that runs here, that the workflow runs that escapes this kernel, it can then it can then lead to issues with other services that are running over the same VM, right? And so that's basically the isolation problem. To be noted here that though the workflow could compromise in theory this thing here, it can't compromise everything. It can't compromise the OS kernel which is running here, right? And so it's definitely preventing that kind of isolation. Um, and the problem is worse like with Linux desktop, especially if you're running like Docker CE. Now Dylan figured out that if you're running Docker desktop, it's still okay because it still spins up a VM. But let's say you're running like Docker Community Edition, or you're running Container D directly, or any of these. Basically, you're actually sharing your operating system kernel with those containers as well. And so if there's a container escape here, that can actually impact your operating system processes as well, in theory, right? And again, these container escapes are not easy to do. Certainly it's possible, but these vulnerabilities are difficult to exploit as well. It's not like very easy to exploit a kernel vulnerability here. But still, it's possible, and it's possible if you like run as root or run a privileged container or increase capabilities. It becomes more probable, but we don't do any of those for workflow. So I want to talk about a solution to this problem. And so the idea is this project which I'm talking about is called Sandcastle, and basically the idea is to have stronger isolation for your workflows. And fundamentally, this project's very simple. Basically, we use VM isolation instead of container isolation. So the idea is that instead of having workflow and my service share a kernel, we spin up a VM on its own, which runs workflow, and a VM that runs my service. So they run separately, and so the kernels are separate. And so even if there's a container escape, it's kind of stuck in the VM, right? Cannot escape out and impact other services running. And the idea here is really simple, that we have a Sandcastle binary, and the Sandcastle binary basically uses either QEMU or VZ or WSL2 to spin up a VM. And that VM then is running on the base OS kernel, and that VM is separated out, right? And so we use for the POC, I'm using Lima basically, and Lima uses the underlying technologies, whether it's Linux or Windows or Mac. It kind of uses the corresponding tool to spin up a VM. And then we have in order to like make sure that customers can easily switch between like Sandcastle or using regular Docker, what I'm doing is I'm using the same Docker Engine API and exposing a Unix socket here. And the Unix socket is same. So we just have to switch the socket that the language server or the Docker CLI uses, and then you can just spin up containers using Sandcastle. Um, and basically, we don't need to really conform to the full Docker Engine API. We just need to conform to the bits that we need for your workflows, which is basically just the ability to spin up a container, copy archives to it, and run commands. Right? Basically, that's essentially all we need. And so that's the idea here. So Sandcastle really acts as a API provider for the Docker Engine API, and then behind the scenes, it spins up VMs, right? So that's really the thing. So I'll show you this Sandcastle in action. Again, this is very simple to use because simple to write, because all I did was use Lima behind the scenes. So I use Lima, which is a Go project, and I use that to spin up the VMs. So let me show you this in action. So I am going to So the way you use Sandcastle is you just use the binary. So I'll show you the binary mode. By default, so I could say Sandcastle start, so sc start, and that actually starts up a VM. I'm not going to pause this video so you could see that how much time it takes to spin up the VM. Now it definitely takes a bit longer um, than a container, obviously, but it's not too fast. It's not too slow, and I'm essentially using Alpine as that base VM. But we can change the image so that you could provide an image of a different OS. For example, if you want to run Ubuntu, you want to install your dependencies in there, you could do that. All right, so we're just going to wait for the VM to come up in a second. And you can see that it's starting like the requirements, and now we've got the VM actually started up. So now let me just increase the font here. Now we can run like commands on this VM. So I could say bin Sandcastle, and then I can run, let's say, uname -a, right? Oops. Run. So Sandcastle run, uname -a, and you can see that although I'm on a Mac here, it's saying, hey, this is running Sandcastle, this is Alpine, and this is GNU Linux, right? And so I could run commands like ls -ltr, so that this is now listing what's in my thing. So another thing I'm doing as a part of Sandcastle is I'm mounting just this project folder. So wherever I run the start command from, I'm mounting that project folder in here, right? And that runs Sandcastle. I can even use limactl to do a list, and you can see that it's showing me that VM is running, right? So because limactl kind of is using the same stuff, you can see the VM is running. We can also restrict like the CPUs and memory and disk space, etc., if you had to. So that can be done as well. So with that, let me show you the API as well. So we'll clear this. And so all I need to do to run the API is say Sandcastle serve, and that actually starts up a Docker socket and the Docker API, the Docker Engine API essentially. So now if I were to use any of the commands, so the language server today uses the API directly. So let me just copy some of those commands. So for example, if I want to spin up this hello world container, I could do that. So I could say this, hello world. We ignore the image for now. I'm not running the container. Oops. I'm not running the container itself. So this is just going to go ahead and create a new VM. And if you see, it creates a new VM. It calls it rough sunset. So it gives this random name to every VM. So every container, quote unquote, kind of is a VM, and each VM then has a name. So if I say limactl and list, you can actually see that it's created this new VM here called rough sunset, and it's running. Each of them are kind of listening on their own port and have their own kind of constrained environment here. And they only mount the folder, which is the current workspace folder, which is being passed via the API. So we pass the mount path many times in the API, and so it'll only use that mount path when it's creating the container. So we have the container running, and now if you wanted to run a command in the container, like calling the start command here, I can just say start and run that, and then oops, I need to give it the right container name because that's what the Docker Engine API needs, and that was called rough sunset. And so if you see, it ran that hello world command here in the container. All right. So that was a rough POC of Sandcastle. The code is very rough at the moment. It's I just wanted to make sure we could get this running. I haven't tested it on either Linux or Windows, and just on my Mac, but in theory it should work. Lima is the same technology that is used for Rancher and Colima and all these to run on multiple environments, so hopefully it should work. Of course, the disadvantage of this method, although it offers better isolation, the disadvantage here is that it takes much longer for the VM to come up as compared to Docker itself. That's it for Sandcastle. Hope you like this. Thank you.